We're going to look at an example involving sum and difference identities. The identities are in your formula sheet or in the book, but here's the problem. We're going to have sine alpha is 3/5 and sine beta is 5/13, and we're told they're both in quadrant 1. That'll be important in a minute. We need to find the sine of alpha plus beta and the cosine of alpha plus beta. The very first thing you absolutely must do is draw these triangles out. Now they're both in the first quadrant, so I'm going to put the first one here on the right hand side. So I've got my XY axis, and I'm going to draw a little angle here. Now it's clearly not drawn to scale, but this angle here is alpha. Now we're told that the sine of alpha was 3/5, so that's the opposite over the hypotenuse. To find that third leg, you're just going to use the a squared plus b squared equals c squared, the Pythagorean theorem. So you have a squared plus 3 squared equals 5 squared. So a squared plus 9 equals 25. I'm going to subtract the 9 over and get a squared equals 16. So a is a 4. So I know this one is of length 4. That's for the triangle or the angle alpha. I'm going to draw another little triangle, again in the first quadrant. This one I'm going to label as beta. And from the previous slide, we said the sine of angle beta was 5/13. And again, I need to find that third side, so I'm using the same Pythagorean theorem, and I'll have a squared plus 5 squared is equal to 13 squared. So a squared plus 25 is equal to 169. I'll subtract the 25 over and get a squared is equal to 144. So I take the square root of both sides and get a is equal to a 12. Right, so this is a 12 right here. Okay. Now that we have these triangles, we can go ahead and try to solve these identities, find the sum. So from the triangle, what I know is the sine of alpha. Of course, we were given that. The sine of alpha was 3/5, and the sine of beta was 5/13. Again, this is what we were given. But from those triangles that we just drew, I now know that the cosine of alpha is the adjacent over the hypotenuse, so it's 4/5. And the cosine of beta, we just solved for this, is going to be the adjacent 12 over the hypotenuse of 13. So we know all this stuff. Now I'd like to find the sine of alpha plus beta. But from our identity, we know that this is just the sine of alpha times the cosine of beta plus the sine of beta times the cosine of alpha. So just filling in what we know that the sine of alpha is 3/5, so that's 3/5 times the cosine of beta, and the cosine of beta is 12/13, plus the sine of beta, which was 5/13, times the cosine of alpha. Cosine of alpha was 4/5, or is 4/5. I'm just going to multiply these out. 3 times 12, there's 36 over 65, plus 20 over 65. So my answer is 56 over 65. We're done, and that deserves a better color, so let's go here and make a nice red circle. We're finished. We found the sine of alpha plus beta. But that's not all. We were asked to find the cosine of alpha plus beta. And again, I'm just going to write down what we know. We knew the sine of alpha, and this was given as 3/5. We know the sine of beta was 5/13. And again, this is the same from the previous line. We know that the cosine of alpha is equal to 4/5. And we know that the cosine of beta was equal to 12/13. So now we're asked to find the cosine of alpha plus beta, and I'm going to look on my formula sheet and I'm going to see that the cosine of alpha plus beta is equal to the cosine of alpha times the cosine of beta minus sine alpha times sine of beta. And again, I'm just going to fill in what I know. Cosine alpha is 4/5. Cosine beta is 12/13. So I multiply those two together. Minus sine alpha is 5/13 times, I'm sorry, sine, not sine beta, but times sine alpha is 3/5. And let's see, multiplying those together, what do we get? I am going to get 40, let's see, yeah, 4 times 12 is 48/65 minus 15/65. And I will get there, when I subtract that, 33/65. And again, I'm going to use a different color. So that's the answer. That's the solution to the cosine of alpha plus beta is 33/65.